Okay, so this will be our third and final example for now. We'll certainly do more once I get back. But this one is, again, it's a little different. They're all sort of unique problems. We are trying to build a rectangular pen with some fencing. But because of the way the land is situated, maybe there's a slope that makes one direction more difficult than the other. It's more expensive to build the horizontal sides than it is to build the vertical sides. And our job is to take the $1,000 that we have in our budget to build the pen and make the biggest one we can. In other words, make the one with the maximum area given our budget. All right, now the description vertical and horizontal is intended to convey this. Right, we've got an overview of some rectangular pen. I'm going to let X be the vertical sides and Y be the horizontal sides. So it's the Y sides that cost $7 a foot, and the X sides cost $5 a foot. So here we have $5 per foot, and for the Y sides, $7 per foot. All right, now our area is the target function. So area is not too bad, it's X times Y, but like the other ones, it's in terms of two variables, and we really need it in terms of one variable. So this is where we have to use a constraint, right, which is basically a budgetary constraint in this one, to figure out a way to write one of the variables in terms of the other. So here the constraint maybe is not quite as straightforward as the other two we've done, because you have to think about not just how much fencing you're using, but what that fencing is going to cost you. So let me write the cost now. Maybe over here is good. So we have two sides, right, that have dimension X that cost $5 a foot. So that's going to be 5 times 2X. We have two sides to the pen that cost $7 a foot. So we have 2Y times 7. And that has to total $1,000. In other words, 10x plus 14y equals 1,000 is our constraint. So we need to solve for one variable in terms of the other. And because of the coefficients, I'm thinking ahead a little bit. Dividing by 10 is easier than dividing by 14. So I'm actually going to solve for x in terms of y. It's okay to do it the other way and get y in terms of x. You'll get the same value. It's just that this might be a little bit less messy. So if I solve for x, I get 1,000 minus 14y, and then if I divide by 10, I get a nice even 100 minus a 1.4y. So this gives me x in terms of y, and I can now put that in to my target. So this is 100 minus 1.4y times y. Right. Now the y we can multiply through. And once we have this, now we're kind of back to maybe more familiar ground where we just need to maximize a function. So we take the derivative, set it equal to 0, see if there are points where it doesn't exist, and then test them. Again, we'll use the second derivative test. So the first derivative is 100 minus 2.8y. Set that equal to 0, because it exists everywhere. And we get y is equal to 100 divided by 2.8. that's 35.71. So that's my only critical point. If I do the second derivative test, a double prime is a minus 2.8. It doesn't matter what y is. This is negative always, which means the function for area is concave down always. And so our one critical point has to be a relative and absolute max. So this is absolute max because the second derivative was negative. Negative for all possible values of y, and so this one, if it's a relative max, is also an absolute max. Okay, but the problem was to find the dimensions plural, and so we have to plug y back into x. So we get 100 minus 1.4 times 35.71. I get 50. So the dimensions then, our final answer would be the pen have x equals 50 feet for the vertical side, and y equals 35.71 feet for the horizontal side. All right. So those are my dimensions. Notice that this does make some sense in the context as well, right? The y dimension is more expensive than the x dimension, and so we have a smaller y dimension than we do an x dimension, right? We use less of the expensive fencing and more of the less expensive fencing. All right, so those are our three examples. Feel free to shoot me an email with questions about any of them. While I'm out of town, I'll be checking email and responding as I can. But of course, once I return, we'll have another day on this to do more examples and hopefully clear up any issues. All right, thanks. I will see you next week.